Hello, this is Mr. Wynn with solving two variable systems of equations. So first off, a system of equations is two or more equations that have the same variables. To solve one, we have to find the ordered pair that satisfies all equations at the same time. There are three main ways of solving. First is graphing, although we mostly sketch in this class. That won't get the exact spot since our graph isn't drawn to scale, but it should tell us which quadrant it's in, or if they cross at all. Substitution is a pretty simple thing to do. If you can solve for one variable, you just plug into the other and then solve that remaining equation. Or last and the best option is elimination. That gets rid of a letter right away and it gives you just one equation left to solve. And once you know one letter, you just plug it in to find the other second letter. But our process will be to use elimination. We turn two equations with two letters into one equation with one letter. If it's one equation with one letter, you can always solve that, get your answer, and then just plug that back in. There's some vocabulary. Make sure you know them. If the two equations, two lines touch, they're consistent. There's a solution. So, for example, this touches right here, and this touches, they're the same line on top of each other. It touches everywhere. So that's consistent. These two over here do not touch at all. They're parallel. There's no solution. If they don't touch, we say inconsistent. So inconsistent is another word for no solution. Consistent means they cross at least once. If you say they touch, if they say consistent, you gotta use one more word, and that's independent, meaning there's only one solution, they touch once, or dependent, they have infinitely many solutions if they're the same line. So inconsistent is by itself. If you say consistent, you must follow up with one more word. Independent for one, dependent for infinitely many. Alright, this one says solve by graphing. This first one, it's an AHK form where it says linear. It's vertically stretched by 2 and it's down 10. So I'm going to sketch that. So I'm starting down 10 from 0, 0. That's 0, negative 10. It's a vertically stretched line. So there we go. Then we have the second one. It's also linear. It's flipped, so negative slope, upside down. It's vertically stretched, even more so than the other one, and up 8. So I'm going to use red right here. So I'm going to go up 8. If that's down 10, up 8 somewhere over here. I'm going to draw a diagonal line, but I'm going to flip it and make it vertically stretch. It should be more stretched than the other one. Alright, so we see that these two lines do cross somewhere right here. I just know it's quadrant 4, but I don't know what that exact point is because my picture's not drawn to scale. If you draw a perfect graph, then you could just read it. But these do have a solution. This would be consistent because there's a solution, and independent because there's just one point. Alright. Solve by substitution. So for substitution, see if one of the equations has a letter by itself or really close to by itself. The first equation has x right here. I can solve for x here pretty easily by subtracting 5y both sides. So I minus 5y minus 5y, I get x equals 3 minus 5y. I can now plug that x in for this x right here. So now my equation 3 parentheses x turns into 3 minus 5y. Then there's another minus 2y equals negative 8. If I distribute and solve like normal, I get a one variable, one equation. So that's 9 minus 15y minus 2y equals negative 8. Combine like terms. 9 minus 17y equals negative 8. I'm going to subtract 9. So that makes it negative 17y equals negative 17. Then I'm going to divide by negative 15. Y equals positive 1. We found y. We now have to find x. To find x, you just plug in that y into either of the original two equations. I'll use the first one. Or you can use this one as well if you did not make a mistake. But to be safe, I'll use the original. So it says x plus 5y, or y is 1, equals 3. I multiply 5 times 1 is 5. I subtract, I get x equals negative 2. We found x and y. The answer is a coordinate, a point. So make sure you put in parentheses, negative 2, comma 1. Alright, so that's the point where those two lines cross. If I graph them on picture, they intersect and that's quadrant 2. And also because there's a solution, we know this is consistent. And because there's just one point, we're going to say independent. Alright, last slide. Solve by elimination. So this problem is really bad for substitution because to solve for b, I'd have to divide and have fractions. Or to solve a by itself in either equation, I'd have to divide and have fractions. So elimination is how you avoid fractions. Elimination says make sure the two equations, well, you pick a letter, so let's pick A. They have to have the same number with different signs. So I can fix this. Where does 3a and 4a match? Well, they meet at 12. I'm going to multiply this first equation, the entire equation, by 4. So I distribute this to everything, to both sides really. I get 12a plus 8b equals 28. And for the second equation, I also need 12a, but I need a different sign. Again, same number, different sign, so I'll multiply this one by -3. I multiply all three of those, I get -12a minus 18b equals +12. Those two new equations are now ready for elimination. Elimination is just add downwards, go straight down. +12a minus 12a, those cancel out to 0. 8b minus 18b, that's -10b. And then 28 plus 12 is 40. So what the sign is what you do. So in the middle I had +8 minus 18, that's -10. And on the right side, +28, +12 makes +40. This is our brand new equation that only has one letter. To solve it, you just do one step, you just divide. Divide both sides by -10. I get b equals -4. Once you find b, you got to find a by plugging in. I'll use one of the two original problems. I'll use the first one. They're smaller numbers. So 3 times a plus 2 times -4 for b. 7. I'm going to multiply. 2 times -4 is -8. I'm going to add 8. 3a equals 15. And then I'm going to divide. A equals 5. So we found a and b. Make sure you put together as a coordinate. So it'd be 5, -4. Put the coordinate letters in alphabetical order. Alright, again, this is consistent because there's an answer. And independent. Alright. One side comment, if you do a problem like this and you get 0 equals 0, that means infinitely many solutions. Let me do that. So, hold on. I just now you see this. So while doing substitution elimination, sometimes all the letters cancel out at once. Instead of just eliminating one thing, two things get eliminated. If so, check to see what's left over. If that's true, then there's infinitely many solutions. Usually you'll see 0 equals 0. So that is true. We're going to say infinitely many solutions. Because they're the same line, if that happens. And if you want to classify that, you would say consistent, because they do touch. They're the same line. You're going to say dependent, because they're the same line. Infinitely many solutions. Alright, if what's left over is false, sometimes you'll see 0 equals 40. That's wrong. If you see that, you say no solution. And again, when you see no solution, they don't cross at all. They're parallel, really. You're going to say inconsistent, and that's it, one word. Alright, and that's it for the video. Thanks for watching. Make sure you ask some questions, class. See you soon. Bye.